Okay, welcome to chapter 15, static electricity. Okay, first of all, we need to look at what's inside an atom. It has the nucleus, which consists of the neuron and proton. Protons are positively charged, while electrons are negatively charged. The neurons are uncharged, so they're electrically neutral. The unit for electrical charge is in coulombs, capital C. The amount of charge for one proton or electron is this value. Okay. So what we need to know is light charge repel and light charge attract, which is the same as in magnetism. So, light charge are like this, they repel each other. Then unlike charge attract. Next, there are electrical insulators as well as electrical conductors. Electrical insulators, the charged particles, such as electrons, are not free to move about. Whereas in electrical conductors, the electrons are free to move about. So, there's two ways of electrostatic charging. First is by friction, okay, which means we rub materials such as silk and glass together, we rub them together, because by contact, the electrons move. So let me re-emphasize, only the electrons can move. The protons cannot move from the nucleus. So you can see the electrons transfer from the glass rod to the silk. So now the glass rod is positively charged. So because silk is a non-conductor, the electrons cannot move freely, and they only remain on the surface of the silk. So this is called charging by friction. Next, we have charging by induction. So it's like a non-contact way of charging. Once again, only the electrons can move from the conductor. Here we have two metal spheres, and we are going to charge them by induction, which means the non-contact charging, non-contact induction. We have two metal spheres, A and B. They are placed side by side. They are touching each other. Okay, so when I bring a negatively charged rod, what happens is that the electrons get repelled from A. So electrons move to the corner of B. Then what I do is that I separate the two spheres while maintaining the rod. You can see that the rod is still here, still repelling the electrons to B. Then after that, I will remove this rod. Now leaving both spheres on its own, there will be one positively charged sphere, which is A, and one negatively charged sphere, which is B. That is charging by induction. Please take note that sphere A and B will have an equal number of opposite charges. Next, there's another method by charging a single metal conductor by induction. Similarly, I have a positively charged rod. Now it attracts the electrons. The electrons move. Okay, so electrons are drawn closer to the positively charged rod. I now ground the positively charged side. When I ground, I'm actually allowing electrons to flow from the ground, which is a sea of delocalized electrons, with unlimited electrons going up to neutralize the positively charged side. So after it's neutralized, you realize that the charges are gone. And when I remove the rod, I get a negatively charged metal conductor. This. Okay, so now after I charge a metal conductor, I want to discharge the metal conductor. So how do I do that? I can discharge by heating. Okay, by heating or by having humid conditions. Because in the air, there is ionized air particles. You can see here, and ionized air particles that will neutralize either a positively charged rod or a negatively charged rod. Okay. So, and also the heat from the flame also ionizes the air particles, which can help you discharge the rod. Another way is by earthing. This is the symbol for earthing. So we're providing a path for the excess electrons to flow into the ground or from the ground up into the conductor, depending on whether is it positively charged or negatively charged. Next, electric field. Electric field is a way where we can sort of visualize how the charge or the electric force that the charged particle is experiencing in an electric field. Okay, the electric field also gets weaker as the charge moves away from the electrical field. So electric field is a region where electric charge experiences an electric force. And this charge is usually a positive charge when we use to draw the electric field. Okay, so drawing our electric field lines. So imagine I'm a positive charge. How will I move with respect to another charge? So if it's a positive charge, I'll get repelled away. That's why the lines are away. Similarly, using a positive charge, if I see a negative charge, I'll get attracted to it. So the electric field lines for negative charge is towards. So the direction of the electric field lines give the direction of the force acting on a positive test charge. This is the positive test charge. So we also need to know how to draw the electric field lines pattern for two charges. So if we will have a positive charge and a negative charge, you realize that the direction is towards the negative charge. Towards negative charge. But if we have two similar charges, you realize that there is a zone here, a dead zone here. So it's being repelled away. It's being repelled away from each other. Okay, you look the same for a negative, two negative charges. Just that the arrows will be in a different direction towards the charge. Okay, there's possible danger or possible potential hazard of electrostatics. So one is lightning. Okay, you can read this. So there's another one that is transfer of fluid and dry bulk. Okay. As the bulk goes through a hose, friction on the inner walls creates electrostatic charging. And this is dangerous if you are an oil tanker. Okay. So if you have fuel and it's combustible, it may catch fire or cause an explosion. So what do oil tankers do? They usually discharge by having a metal chain at the bottom. Okay, so at the bottom of the car, you see a metal chain. This acts as a connection to the ground, which is the same as earthing. So they can discharge. One that you need to know for your syllabus is electrostatic precipitator, which is another word for your ionizer. So how does the ionizer work? The incoming gas has unwanted particles, so it enters the precipitator with all the unwanted smoke particles or dust particles. Next, there is two wires. You can see this wire here, one here. Okay, that carries a current. So this negatively charged wire actually ionizes the dust particles. So it ionizes these dust particles. So ionizes dust particles. And then they have two electrostatic plates that's positively charged. And all these negatively charged dust particles will get attracted to the two positive plates and get stuck to the plates. And after that, the clean air will come up on the other side. Then next, what we have is a hammer that knocks the plate to let the particles fall down and being collected at the bottom. Okay, you can read this example on your own. And that's all for this topic.